Good evening, everyone, and welcome to the Real Science Exchange, the pubcast where leading scientists and industry professionals meet over a few drinks to discuss the latest ideas and trends in animal nutrition. Tonight, we're recording our next edition of the Journal Club, and with us we have Dr. Bill Weiss. He's our resident professor here at the Journal Club, and Bill, typically I'm looking at you through a computer screen, and I got to tell you, I like this a lot better. You're a lot better looking in person. So.
Usually it's the opposite, I hear. So.
No, I'm looking forward to this. Tonight we're actually recording at the Tri-State Nutrition Conference, and that's why we're here in person. And then we've also got, this is the 2022 Tri-State Nutrition Conference. I've also invited one of the organizers, Dr. Maurice Eastridge from the Ohio State University, and Maurice, I was going to ask you what's in your glass tonight, but it looks like you're our designated driver.
That's right.
Okay.
Pure clear.
Good stuff. Why don't you start off by telling us a little bit about the Tri-State Nutrition Conference and then kind of give the audience an idea of why they should come to the 2023 conference.
Yeah, great, Scott. Thanks very much for having me here and spotlighting the Tri-State Dairy Nutrition Conference. This is our 30th conference, and so we're very proud of that as Michigan State and Purdue University and Ohio State University have worked together for 30 years to host this program in conjunction with our industry support. That's really what's made this possible. So looking at next year, it's April 17th, 18th, and 19th back here in Fort Wayne. All 30 years we've been in Fort Wayne. Been a tremendous central location, but we also draw from Canada and several other countries as well. It's great to be back in person. 2019 was our last time here until this year. In 2020, we had to cancel. Everybody knows why. And then in 2021, we went virtual. And so it's really good to be back. Everyone seems to be excited. Our exhibitors are back up in number of 50. I think we have around 54 exhibitors. Attendance has been good, and so we're excited. Thank you.
Yeah, awesome. Well, we thank you for coming here tonight. We know you've got some other things you got to do, and you won't be sticking around for the whole podcast, but we appreciate you stopping by.
Well, thank you, and thanks for Balchem and the mini symposium you did yesterday that went really well and supporting the whole conference.
Yeah,
appreciate it.
You're very welcome. Bill, so what we do here at the Journal Club is Bill picks a paper once a month, and we get together with the authors and professors with the papers, and we review it. I guess these are a little kinder review than maybe some that take place in traditional universities, but why don't you kind of give us a background on the paper that you've selected for today and why you selected it? And then maybe after that, introduce the guests that you brought with you today.
Okay, Scott, the paper I picked is, the abbreviated title is basically Reducing DCAD on Lactation Performance, Nutrient Digestibility, and Ammonia Emissions from Manure. I picked this for a couple reasons. One is we all know environmental issues are only going to become greater and greater in dairy. And this is a new way to reduce that really hasn't been investigated to a great extent. And then just the idea of feeding lower DCAD to lactating cows, that's adverse to everything we're taught. So it's, I think, just a new approach, something different. The other reason is I am well familiar with the main author of this paper. I worked with him for many, many years, Dr. Lee. And then this is the master's project of another student, a former student we have here with us as well, Haley. So I'll turn it back over to them to kind of introduce themselves.
Yeah, I'm glad to have you guys with us. But, Bill, I forgot to ask what's in your glass tonight.
Okay. I have a Spotted Cow beer, which I get to drink about once a year when I visit Wisconsin. So This is a 2-time-a-year time.
Yeah, Spotted Cow in Indiana. That's awesome. Dr. Lee, what's in your glass tonight?
I got Spot Cow as well. This is the first time that I tried this one, and it's pretty good.
Super. Thank you for joining us tonight. Give us a little bit of background about yourself.
My name is Chanhee Lee. You can call me Chan. I'm an associate professor in the Department of Animal Science at Ohio State University. I started my position in 2015. I got my PhD at Penn State University. I had some postdoc experience in Canada for 2 years, and I started my position in 2015. And my research area is dairy nutrition and nutrient management. And this work that we are going to talk about is related to dairy nutrition and nutrient management as well.
Super. And Haley, welcome to the Real Science Exchange. Glad to have you here.
Thanks for having me. I'm glad to be here.
Yeah, tell us a little bit about yourself and what are you doing with your great Ohio State education?
Sure thing. So this was my master's project, of course. I finished it up in May of 2021, of course, in dairy nutrition. And now I'm still with Ohio State University, but in a little bit of a different capacity. I am the agriculture and natural resources educator in Ohio's foremost dairy county, Wayne County, Ohio. So I'm glad to be putting it to good use, that's for darn sure.
Super. And I'd be remiss if I didn't introduce my co-host, Dr. Clay Zimmerman. Thank you for joining us once again. And what's in your glass tonight?
I have the usual. I have an Angry Orchard.
Yeah, good.
This evening.
I'd be disappointed if you didn't, Clay.
Yes.
All right,
Yes.
very well.
Tonight's Pubcast toast is brought to you by NitroSure Precision Release Nitrogen. Maximize rumen microflora with the consistent release of NitroSure to turn up the dial on rumen efficiency and productivity. Visit balchem.com to learn more.
And with that, Bill, I'll turn it over to you to lead us through the discussions.
And I don't, John and Haley, answer whoever is appropriate. I'm not going to pick out names, but I guess we always want to start out, what's the hypothesis of this experiment? What's the idea behind it and your hypothesis?
So maybe I can start. So we came up with the idea for this project because we always have been thinking about how we reduce the environmental impact from dairy production. I think one of my interests was to reduce the ammonia emission from manure because we talked about a lot of gas emissions from cow and from manure. We recently talked a lot about methane emission, but I think if you look at the dairy contribution to total gas emission in the United States, ammonia is number one from dairy cows, manure. So I have been thinking of how we can reduce ammonia emission from manure. Maybe it's possible if we can manipulate diet and we can manipulate manure characteristics, then it's possible to reduce the gas emissions from manure. My target was ammonia, and that's how I came up with this idea.
And then again, maybe for the audience, the principle behind DCAD and reducing ammonia. What's the mode of action?
So this is the interesting part. You probably saw quite a bit of papers about DCAD for prepartum cows or lactating cows. For lactating cows, preferentially, we try to increase the DCAD to improve production of dairy cows. But this idea that we had is to reduce the DCAD for lactating cows, because if you reduce the DCAD, then there will be more anions supply. Then that create the imbalance between anions and cations, and that increase the hydrogen ions in blood, and that should be excreted in urine. That is how urine pH is decreased. If that is true, if that is the case, and if we can decrease quite a bit of urine pH, then probably it's a good opportunity to reduce ammonia emission. We also expected some negative effect on production because that's what have been studied. Reducing DCAD have some negative effect on production. For example, milk fat, the feed digestibility, or dry matter intake as well. But what we want to do, we wanted to try some diet manipulation to reduce, to manipulate manure characteristic and reduce ammonia emission. To show the opportunity, this is another opportunity that we can try to reduce gas emission from manure.
Ali, can you maybe, why would pH in ammonia be manure ammonia? What's the connection there?
Yeah, so that was actually kind of a high point, and I'm glad I was able to bring this research into some of my recent fertilizer sessions, with manure being so incredibly important right now. So pH and ammonia are tightly tied together in the way that by reducing pH of manure or the manure slurry, we're able to decrease the amount of ammonia volatilization simply through decreasing the amount of ammonium ions that can shift back and forth between ammonium and ammonia. So by dropping that pH further away from 9, or its pKa, we're able to decrease the number of ammonium ions in the manure from transferring to ammonia and then further volatilizing into the ammonia gaseous state that we can smell when we walk into a barn or we're on the manure lagoon.
You're basically trapping. You're not reducing the amount of ammonia produced. You're just trapping
it. Yeah.
And like
So another point is, if we trap the ammonia, we can increase the value of manure as fertilizer. That was another point.
and right now that's a very, very big point.
Oh, yes.
So you're trapping the ammonia as ammonium
Correct.
in the manure?
Yeah.
Correct. Yes.
And this, there's two projects in this, and I want to emphasize or spend most time on the cow project. But you did what I call a proof of concept experiment in vitro. Can you briefly discuss what you did and what you found? But again, I want to, most of the time, I want to talk about the cow experiment.
Sure thing. Did you want me to start on that?
Yep,
All right. So sounds good. So proof of concept, we essentially took manure samples from 4 different cows and composited this manure together, I should say the feces and then the urine separately, so that we could create a sort of homogeneous mix of cows all on the same diet. So from that, the urine was a typical 8.5 pH. Feces was a little bit less than that, in that 7.5 range. And so from there, we split that composited feces and urine out into 4 different aliquots. And we had, of course, our control or our base, which was the unaltered manure. And so then we went forth and included sulfuric acid into, or I should say we composited this manure then into a 2-to-1 ratio with feces and urine, and then included or added sulfuric acid into this slurry to drop that pH down to 7.5, 6.5, and 5.5, and then incubated from there to see, if it will actually work. If through adding a strong acid, which has been demonstrated over in Europe, that's a pretty typical way of trapping that nitrogen in the manure. If we could do that and show how much ammonia volatilization, loss we would have. And so we were able to do that. It was about a 20% at least decrease in ammonia after we incubated and measured those air samples. So we were able to demonstrate the fact that by biologically reducing that manure slurry through diet manipulation, we should be able to see some sort of decrease in nitrogen loss.
How long do you incubate these things?
We incubated those for, I believe 5 days. Okay. And so through the incubation process, the manure is placed into gallon glass jars, and every 24 hours, the gas bags or the air collection bags are switched out, and the air is sampled for 30 seconds every 30 minutes for those 24 hours. And so after we switch off the bags, we're able to then measure using a gas measurement device and get the concentration of the gas particles we're seeing.
Okay. So one more thing that I want to add is in this in vitro trial, what we wanted to know is how much urine pH should be decreased to sufficiently decrease the ammonia emission from manure.
And that for the animal experiment, then you use that data to come up with your treatments.
Yep.
Again, I don't care which of you, but now introduce the big picture, the treatments, and what you did on the animal experiment.
Do you want me to do
it? You can start, and I can add, I guess.
So based on the result from in vitro experiment, we conducted the in vivo experiment. We had 27 cows, and 9 cows per treatment in a randomized block design. We blocked the cows by days in milk parity, and then we assigned the treatment to the cows randomly in each block. The dietary treatment was just a normal DCAD diet, we didn't increase the DCAD. When we we just formulate the diet to meet all the requirement also all the minerals. And that is about 200 milliequivalent per kilogram of dry matter. That was the control. And then we decreased the DCAD about half by adding the commercial product, mainly ammonium chloride, to 100 milliequivalent per kilogram of dry matter. And then the last treatment was we decreased the DCAD further to pretty close to the 0 of milliequivalent of kilogram of dry matter. Our target was about 50 or between 10 and 50. But after we analyzed the samples, after we finished the experiment, sample analysis, we calculated DCAD of the diet, and that was the actual DCAD that we got for the third treatment.
And because this is ammonium chloride and you're measuring ammonia, how did you adjust for that? Because that's going to should increase
that's good point. So if we provide ammonium chloride, that provide the additional nitrogen compared to other non-ammonia nitrogen to the diet. So we try to include urea for other treatment to balance out RDP and RUP concentration in the diet. So I'm not saying there is exactly the same effect between urea and ammonia, but I think that's the best approach that we can do to balance out the diet.
I think it's also important, these were very high corn silage diets. So pretty, I won't say low, but marginal in potassium, which I think had some effects on your results.
Right, that's true.
And again, if you want to kind of briefly go over the production data first, and then we'll spend a little more time on the ammonia and digestibility data.
Sure. So with the production data, the milk fat was probably the most interesting result that we had. We were expecting some sort of decrease in milk production, especially with that low DCAD diet being near 0, or at least, and then also some milk fat depression probably. However, we saw milk fat depression across all 3 diets, something definitely not expected, especially with that high DCAD or typical DCAD type diet. There were some numerical decreases in overall milk production, but that also went along with the numerical decrease in the dry matter intake.
The fats were really low. I mean,
effectively made skim milk.
But you look at the diet on paper and it looks just fine and dandy.
Right, right.
So we actually changed part of the discussion during the review process. I think I included that description in there. What we found at the time, I looked at the milk fat content of the whole diet in our research center, and they're all low. So I thought that something is wrong. So what we found is the fat supplement that we used, basically fat supplement should include some linoleic acid. I knew that, but the concentration should be pretty low. But when I contact the company, they send me the fatty acid profile of the supplement over the month, last kind of a year, every month's analysis data. And their linoleic acid concentration in the fat supplement was just like fluctuating. And then when we used that supplement, the linoleic acid concentration was huge. So I think that's a part of the reason why we saw the milk fat depression in our whole diet, in our research center and in our experiment. And also another reason is we used a very high corn silage diet.
So the high corn silage diet, just for those of you that are listening, the high DCAD diet, the milk fat percent was 2.52%. So they were all quite low.
Yes.
And then again, kind of summarize so no effect on milk fat, no treatment effect on milk fat. What else did you find on?
But one more thing that I want to add in terms of milk fat, if we didn't have that problem that caused the milk fat depression for our cows, if we had just the normal fat, and maybe the milk fat decreased by the low DCAD diet might have been larger. So probably all cows had very low milk fat. That's why some of the effect of low DCAD was masked. So just want to point it out.
Okay, so what else did you find, again, with respect to treatment now and production data?
In looking at some of the results, there's always that trans 10 shift. So we saw that CLA in the milk fat, and that I believe tended to increase with the decrease in DCAD. Yep. So essentially, as that DCAD dropped, there were more trans 10 shifts.
Mm-hmm. And on milk and protein and intake, what did you find on those?
Intake decreased, or I should say, are you talking about fatty acid intake?
No, dry matter
intake. So dry matter intake, it wasn't statistically different among the treatments. However, there was a numerical decrease by about 1 kilogram from that highest DCAD down to the lowest. And so that, we can't necessarily attribute it to the low DCAD itself. But then that was also paired with a numerical decrease in milk fat production by about a couple of kilograms from that high to low DCAD.
Don't we kind of, with a 200 milliequivalent change in DCAD, is that about the expected drop in BMI? Or
I would have expected a little bit more. Typically you read that cows are going to sort against that anionic salt, anionic grain mix. And that wasn't the case even when when I went through the refusals and separated that out and did a particle separation on it. That wasn't necessarily the case either. And looking at some of the other references that we used, there was a numerical difference between a couple of different chloride supplements. And so the chloride supplement we used in this paper had the higher of the numerical dry matter intakes. And so we were hoping that it wouldn't drop intake as much as some of the other supplements that could be used.
And intakes were pretty good, I think, across the board. Mm-hmm. And then what about milk and energy-corrected milk? What did treatment do to those?
Chan, I don't know if you want to take over on that one a little bit.
Milk yield, if I remember correctly, milk yield was decreased numerically, and energy-corrected milk decreased significantly. This is because of milk fat, as we discussed earlier. Milk yield, again, there are several factors, the potentials that we can talk about numerical decrease in milk yield. This is it's not statistically different, so maybe it's nothing. But maybe if we used more cows, it was significant. I don't know, but it's possible. Based on the meta-analysis published, there is a clear relationship between DCAD level and dry matter intake or milk yield. So, and we had a numerical decrease in milk dry matter intake as well. This is part of the reason why we saw the numerical decrease in milk yield. But probably, again, we used only 9 cows, which is probably didn't have enough power to look at all the significant differences clearly. So if we used more cows, it would have been significant. But I cannot, this is my guess.
I think, what those meta-analyses you're talking about, if you limit it to lactating cows, almost every experiment increased DCAD. You decrease DCAD. Do you think that could make it different than these other experiments?
So the reason why we started with this concept is actually this is a second experiment. We conducted another preliminary experiment with even less number of cows to see if there is really a huge drop in dry matter intake or milk yield by decreasing DCAD in a diet. We didn't see much difference in dry matter intake and milk yield. That's why we tried another experiment. When I look at the meta-analysis or other designed experiment in the literature, actually quite a bit of papers didn't see any significant differences in production when they compared the actually increased DCAD or when they decreased the DCAD as a negative control. So maybe there is something that we don't know about DCAD. So and also we saw the opportunity to reduce the ammonia emission from manure, which is very good benefit if that is possible. So we try to understand if really how much decreasing DCAD negatively affect the production, and then how much that decreased ammonia emission from manure. That's what we wanted to figure out.
Now let's get to the meat of this paper, and that's the ammonia. What did you find there?
Cumulatively, there weren't any significant differences. I believe for the animal experiment, day 1 was the only day that had differences among the treatments itself. But cumulative emissions, there wasn't quite the decrease we were expecting. It was about a 15 percentage point decrease, which was lower than some of the previous experiments. The other ones done in our lab were showing 30 to 40%. So we were hoping to get at least to 20, but we didn't quite reach it. And so, of course, we didn't reach quite what that in vitro work proof of concept trial showed either.
How much, again, and this is still lab scale, on a farm scale, what would if you saved 15% of the ammonia, do you have an idea of what we're talking about here? Or?
Well, I would have to do some calculations, of course. But right now, I mean, nitrogen's $1 a pound. So keeping as much in the manure as we could would be highly beneficial.
But again, I don't know if you know the answer or not. I don't. Over a 5 or 6 day period on a farm under normal conditions, how much ammonia is it? Half the ammonia or half the nitrogen, or what loss of nitrogen are we talking in?
So if you broadcast apply manure, not necessarily in storage, but if you broadcast apply manure on fields, you're losing at least 40% of the nitrogen in that slurry. Okay,
so 15% could be a lot of pounds.
Yeah, it could.
It's a lot of decrease. We didn't see the significant difference because of a lot of other factors that we discussed in the paper. But 15% decrease in ammonia emission is a huge decrease. It's a huge decrease and benefit for environmentally. For example, it can first of all increase the manure value, and also that can decrease all the farm smells. Not all, but a part of the farm smell can be decreased by reducing ammonia emission as well. And then ammonia volatilization also has an impact on air quality. Those are all local issues, and water quality. Instead of world the problem. So, but it is also very important. And 15% decrease with diet manipulation is a huge impact. But we didn't see the significant difference because there are several factors. But if I have a chance, I'll talk about it later.
I'm curious. With the in vitro study, is that a viable method of reducing the volatility of nitrogen?
I would say it cannot. That in vitro cannot the real situation. It's not real. This doesn't represent the real farm, but at least we can compare if this strategy can increase or decrease the gas emissions from manure. The quantified ammonia emission probably doesn't match with the ammonia emission from real farm, but at least the ranking purpose we can do that.
So there is a paper that talks about different strategies of nitrogen retention using strong acids and other manure amendments. And sulfuric acid is the one that's most highly rated. I believe it's over in Denmark and the Netherlands that they're doing this. And so there's a few different ways that they can effectively add this amendment in, so it can be at the storage level, or it can even be at field application to try to retain some of that nitrogen.
And what would be the advantages of doing it in vivo versus that way?
Well, storage would be one thing. You don't have to handle those strong acids yourself. But if you were also to try to add those amendments to the manure slurry, whether in storage or at field application, you're going to have some extra capital lying around to improve your buildings, improve your manure storage, as well as purchase more equipment.
Yeah, good point.
Yeah, the safety of these acids, handling these acids is really important. I mean, we handle them in the lab, and you can't believe what we have to do. 'Cause you spill a drop on you, and you're going to be in trouble. So, I don't think it's a viable, practical thing because of safety issues.
It makes sense.
So so even the high DCAD diet, there were no buffers added to any of these diets, correct?
No.
No.
So we didn't include the buffer. I know in practice many people include the buffer to increase the DCAD of the lactating cow diet, but we didn't include those.
So that brings up if you do add buffer, you increase DCAD from 200 to 250 or 300. Do you think that would increase ammonia, or are you already at a pH where it's not going to make it worse?
Probably it's pretty much the same. That doesn't change the urine pH much.
Okay.
Increasing DCAD from 200 to 300 or 350, 400, that doesn't change the urine pH.
Where do you think you have to be to get a respectable drop in ammonia without doing too much damage to the production of the cow? Where do you think is a good number?
I don't know, but I think still there is opportunity with DCAD. 100 or 50 or 75, we used almost zero DCAD, which definitely decreased negatively affect the production. But if we can have 50 or 75, if that doesn't affect production much, or no production negative effect on production, but if we can increase volume of urine with that low pH, urine with a low pH, then we have more opportunity to reduce ammonia emission. The thing is, the feces has a pH as well. 7 or 7.5, depending on what we feed. It changes slightly. Because of fecal pH, there is a range that we can reduce the manure pH with urine. So that's quite challenging. So if we can increase the urine volume by decreasing urine pH, there is more opportunity to do that. But we definitely don't want to give a negative effect on production. So that's the first thing. Within that, we want to try something else to reduce manure pH.
So what's the typical ratio of feces to urine in manure?
So when I was a graduate student, I didn't estimate it fecal volume and urine volume to incubate the manure. I did a lot of manure incubation work before. We always assume the ratio is 1.7 to 1, feces to urine, the as-is basis. And I thought that was true. And then after I did a lot of experiment, it's quite variable. And then we found that between cows, the ratio is pretty variable. And what we got was not close to 1.7 to 1 or even 2.2 to 1. So. As
cows produce more, they drink a lot more, and it has to either go out and milk or elsewhere. And that ratio, cows are increasing urine production more than fecal production. So that ratio should actually be widening. And that brings, one of the main drivers of urine volume still is cations. Sodium and potassium are equal, but there's a lot more variation in potassium. So if you wanted to get these cows to, I'll be polite, urinate more, you could have fed a lot of, say, K-chloride.
Yep.
And that would have been neutral on DCAD. Do you think, and it would have increased urine volume, no question. Do you think that would have made it a more positive, or the DCAD having a bigger effect?
I don't know if potassium chloride have negative effect on dry matter intake. I think I saw some papers about intake problem, palatability problem with potassium chloride. I don't know exactly, I don't remember exactly, but there was some concern in old the classic papers. But if that doesn't affect dry matter intake, or just, I'm talking of just the palatability issue or something else. If that doesn't affect the dry matter intake, then we can increase the potassium level without changing DCAD by feeding potassium chloride, and then decrease DCAD with ammonium chloride or something like that. That's another thing that we can try. It has an opportunity as well.
And salt will do, sodium chloride will do the same thing.
Yeah, right.
But again, this adds cost. All this is adding cost. So, do you think this is economically viable with additional? Right now this is still early research, but do you think this could be?
So we saw the quite negative production effect with this strategy. So I'm not. I at this point, at this moment, I say no. This is not practically effectable. We can probably next 5 or 10 years we can improve this strategy with a slightly different approach. If that works, maybe it can be practicable, but at this moment it's not practicable as far as it harmed the production of cows.
I think we all think this is eventually ammonia emission may be taxed or regulated, or there'll be an economic cost to getting rid. So would that change the economics then? If all of a sudden it costs you money if you lose X amount of ammonia?
I think if we can capture the ammonia in manure, if we use this manure as fertilizer and that works well for crops, then definitely there is a positive aspect for that. Problem is, I don't know if producers can recognize that benefit. If they see that and they recognize it, yes, probably it's a benefit. Decreasing ammonia is very important. But I don't know how much this concept or capturing manure with more ammonia change the crop growth. That's another area that we need to look at.
I've been asking most of the questions. I only got one more. You use chloride as the anon, but do you think you'd have got the same thing if you used a sulfate anon? Or
say again?
You use chloride to lower DCAD.
Yep.
Do you think you'd have seen about the same thing if you used sulfates?
So we can change the DCAD equally by using sulfur and chloride, theoretically, but their digestibility or absorption is different. I believe sulfur has less absorbable. And I don't know exactly if there is the same effect when they appeared in blood to increase hydrogen ion and decrease the urine pH. I don't know if there is exactly the same effect between sulfur and chloride. Because if I just think sulfur has a less digestible, then I think chloride is the best way to change urine pH quickly compared to sulfur.
Would feeding these high sulfur there's mineral antagonists and all that, I don't want to talk about that, but these cows will excrete a lot more sulfur in manure, mostly fecal. Is that an environmental issue then too?
So there are two things. If we increase sulfur itself is toxic in the rumen. That's one thing that we need to probably think about if we want to increase sulfur content to decrease DCAD. Another thing is sulfur concentration in manure. If we increase sulfur concentration, it increases hydrogen sulfide emission. That might be another toxic gas that we can have in the dairy farm. But hydrogen sulfide emission from manure is pretty small. I don't know if that emission is going to be pretty toxic for workers or cows in the farm. I'm not sure. But it definitely increases hydrogen sulfide emission. Another thing is, as a manure value, there is studies, agronomic studies starting around, try to increase the sulfur supply when they apply the fertilizer because of a lack of sulfur concentration in soils. If that sulfur is really needed for crop growth, then maybe in terms of manure value, having more sulfur in manure might be beneficial, but I'm not sure.
You had mentioned that you don't think this is at least near term, a viable method for reducing nitrogen volatility, but that maybe 5 years down the road, you might alter your methodology. What might those alterations be?
So what I want to actually do is direct treatment to manure to reduce gas emissions. That is the most effective way. But the acidification or using some enzymes or applying some microorganism, there are many things that we can do to reduce gas emission from manure. Problem is, I don't think people want to spend money to do something with manure. If there is a state level support or federal level support, I encourage to do something, to physically do something with manure to reduce gas emission, not diet manipulation. Because of no support for producers, we are trying to do the diet manipulation to decrease the gas emission, which is the cheap way, not expensive, and cheap is the way to do.
And do you have plans currently, research plans to address that?
We are doing some using some distilled grains to do something to manipulate the manure characteristic to reduce ammonia. We tried DCAD, and I like to try different levels of DCAD, not very low. So I want to try some different levels as well if I have fund for that. We are going to keep trying to do some diet manipulation to reduce gas emission from manure.
So you mentioned earlier that the linoleic acid content of the diets were higher than you expected.
Yep.
Were the other dietary nutrient levels, did they come out the way you expected, or were any of the others different than you were expecting?
I think crude protein level was slightly different, but it was in the expected range. And other than that, it was pretty close.
I mean, the lowest DCAD, we were trying to shoot for that 50 range, but it ended up being lower.
Oh, okay.
Yeah.
Okay.
And I don't know if you mentioned, but these were 16% protein diets, just for the audience.
Yep.
And were the fatty acids in a rumen inert form, or?
It was a mixture between vegetable fat and animal fat. Some of the the fatty acid were polyunsaturated fatty acid.
Okay.
So was the corn silage higher in linoleic acid content than you were expecting?
So that's an interesting aspect of it because there is a paper that correlates starch concentration in corn silage along with linoleic acid concentration in the silage. And that's out of, I believe it's Penn State. And so essentially with high starch corn silage diets, you're also going to have an increased concentration of linoleic acid in the diet, or at least in that silage. And so when our corn silage is measuring 36% starch, we expected quite a bit more linoleic acid. After we had found that paper, we expected a higher linoleic acid concentration than we were initially banking on.
Bill, you mentioned sulfur earlier. So where should we be balancing sulfur in our lactating diets?
0.2. There's 0.25 tops. There's no benefit to feeding more, and there's a lot of risk to feeding more. So 0.2 is a very good number.
So when you added the ammonium chloride to the diets, you reduced urea. Is the rate of degradation of urea and ammonium chloride the same?
I believe urea hydrolysis to 2 units of ammonia in the rumen is very fast, as far as I know. But I don't know. I didn't. There's no way that I can watch it, how that is degraded and utilized. But their hydrolysis should be very fast in the rumen by microbes, and we assume it will be pretty similar.
You on the high DCAD, the one without ammonium chloride, you had 0.5% urea, which is pretty high. And what amazed me is you had really good milk fats or milk proteins. You had terrible milk fats, but for all that urea, those are pretty good milk proteins you had for across the board, all treatments.
Yep.
So you did see a milk protein percent response in the animals. Can you describe what you saw there?
Well, I guess I'm not remembering the protein results as much as I'm remembering the fats. I believe there was an increase in protein? Yeah.
Yeah, there was a linear increase in milk protein percent as you lowered DCAD.
But I think
But
protein yield was not significantly different.
Right.
Is that right?
Yeah, no effect on protein yield, though.
So that is pretty much telling us dilution effect, probably. We have numerically decreasing milk yield, and then it has a high concentration of protein, so then the protein synthesis is about the same between the treatments.
So the other part of the paper I found interesting was where you were monitoring the urine pH levels. So you looked at them throughout the day. So how many times a day were you checking urine pHs? Do you remember?
So throughout, we were measuring pH once a week until that last week of data collection. And then at that point, we were measuring, I believe, every 6 hours. We were taking a look at urine pH and collecting urine and collecting feces to make that final composite. And so the measurement of pH at time of collection was even different from the time of incubation. And so we attributed that to the freeze-thaw process. There's natural buffering effects in the urine pH. And interestingly enough, that came from a human science paper from urine samples in that way. Essentially, that thawing process allowed the urine to essentially buffer itself and increase the pH.
So the diurnal variation really wasn't that dramatic, but you did see some week-to-week differences in the low DCAD diet, correct?
Mm-hmm. It dropped and then it kind of stabilized itself.
And those week 3 and 4 would pop back up for the low DCAD. You know, that suggests maybe they weren't getting the DCAD you thought, or did you sample the feeds enough to?
So I think the problem was the dairy ordered the grain mix every other week, something like that, and always there is a variation between batch that they make at the feed mill. I think that is a part of the problem. That's why we have huge decrease in urine pH, and then stays there, and then increase a little bit, and then the decrease back down. That's how I think what happened.
I do remember taking a look at some of those monthly composite samples, and there was one that was a little bit higher than what I was expecting. So that was likely during that week 3 and 4.
It's time for last call because I am out of a beer.
Me too.
I kept looking over at the bartender. She wasn't moving. So anyway, yeah, they flickered the lights. So that is last call. And with that, we're going to ask you guys one final question. If you'd share with the audience any practical implications from the research, and if so, where are we going to go with this going forward? And I think you've kind of touched on that, Dr. Lee, but maybe just kind of put a bow on this.
Tonight's Pubcast stories are brought to you by ReaShure Precision Release Choline. ReaShure is the most researched encapsulated choline on the market today, consistently delivering results to your transition cows of higher peak milk, reduced metabolic disorders, and even in utero benefits to her calf, leading to growth and health improvements. Visit balchem.com to learn more.
Why don't we start with you, Bill?
Well, like I started, environmental issues are only going to increase. In the past, for ammonia, reducing ammonia, the goal, we always just said feed less protein, and which is good, but there's some disadvantage of that too. So these ideas of whether they work perfectly or not, again, it just gives us a bigger toolbox of ways to reduce ammonia. So I think in the future, things like this may become even more important.
So one thing that I want to add to the Bill's point, reducing protein level in the diet always works to reduce the ammonia emission, but that also decreases the manure value as well. Mm-hmm. You just don't have more ammonia emission from manure. But what I think is recently our goal is to improve sustainability of dairy production. When we talk about sustainability, economically viable the dairy production, and also environmentally friendly, and then We have to maintain the production. There are many things, but my focus is to maintain the production level with decreasing environmental impact. The goal to do that, what we need to do is to improve efficiency of diet nutrient utilization, so we can have less nutrient excretion, but maintaining the production, which is the research goal that I have. If that works, it will be pretty practical.
Clay?
I think this is really important right now, looking at the cost of fertilizer right now. The cost of nitrogen fertilizer is extremely high. So if we can retain more of that nitrogen in the field, that's a huge benefit now.
Very well. Haley, going to give you the final comments.
Sure thing. So a lot of what I'm thinking has already been said, so I won't necessarily echo it. But I think a natural next step in research would be a field trial and trying to grow some of these crops, maybe not necessarily with a chloride supplemented diet, but especially those that are using sulfur to decrease that DCAD, especially for some of those soils that are sulfur deficient. Now that I'm working in extension, I'm looking a lot at the whole farm model. I'm helping a lot with agronomic areas that I wasn't doing necessarily before. And so just trying to get that whole umbrella approach just to see, how it comes full circle would really be important.
Mm-hmm. Super. Bill, this is another good one. I want to thank you very much. You did a great job today. Brought a nice paper for us to look at. Dr. Lee, first time here at the Real Science Exchange. Look forward to having you back again.
Thank you for having me.
Yeah, enjoyed having you here today. Haley, you were a great guest. The industry's in great hands. You're a very intelligent young lady, and so we really appreciate you having you here again. Having you here today, and hopefully having you here again sometime. Also want to thank our loyal listeners for joining us once again here at the Real Science Exchange at the table. Hope you learned something. Hope you had some fun, and we hope to see you next time here at the Real Science Exchange, where it's always happy hour and you're always among friends.
We'd love to hear your comments or ideas for topics and guests, so please reach out via email to anh.marketing@balchem.com with any suggestions, and we'll work hard to add them to the schedule. Don't forget to leave a 5-star rating on your way out. You can request your Real Science Exchange t-shirt in just a few easy steps. Just like or subscribe to the Real Science Exchange and send us a screenshot along with your address and t-shirt size to anh.marketing@balchem.com. Balchem's Real Science Lecture Series of webinars continues with ruminant-focused topics on the first Tuesday of every month, monogastric-focused topics on the second Tuesday of each month, and quarterly topics for the companion animal segment. Visit balchem.com/realscience to see the latest schedule and to register for upcoming webinars.